Good evening, guys. Welcome to today's session. So this is day 3. So we have seen in day 1 and day 2, we have seen domain analytics from 360DigiTMG. So this is day 3. We are going to see EDA and pre-processing about robotics analytics. Okay. So in robotic analytics, we are going to see what are the EDA steps and pre-processing steps we should follow to do our domain analytics. Okay. So moving on, we have seen what is meant by robots, what is meant by robotics. So what are the steps we have to do it, right? So now the thing is, we are going to see what is meant by EDA, what is meant by exploratory data analytics, right? EDA. So exploratory data analysis is nothing but EDA. And we're going to see what is meant by data pre-processing in this data analytics. Okay. So these are the things we are going to see. Okay. So we are going to see what are the steps we have to involve in this EDA, in this exploratory data analysis. Okay. We are going to see what are the EDA steps. Okay. EDA starts by asking some basic questions. You can see of data sets to make an initial assessments of data structures and quality to facilitate a plan of attack. Okay, so EDA, it's nothing but exploratory data analysis. Okay, so this EDA is used by data scientists. Okay, this EDA is used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. Okay, so this exploratory data analysis EDA is used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. Okay, so why is this ED used for? So this exploratory data analysis is an approach to analyzing the data using visualization techniques. It is used to discover trends, patterns, or take assumption with the help of statistical summary and graphical representations. Okay, this is what is known by EDA and why it is used for. Okay, so what is an example for EDA? Okay, we can go for an example using this EDA. We can see what are the hiking of boots, what is the hiking of the shoes, right? Sandals. We can go for this. It is an EDA example. Okay, so this is all about the EDA, guys. So let me explain you once again. EDA is nothing but exploratory data analysis. You can see it refers to the critical process of performing initial investigations on data. So the discover patterns, to spot anomalies, test hypotheses, and check assumptions with the help of summary statistics. As we have seen, as I said, this exploratory data analysis refers to the critical process of performing initial investigations based on what? Based on discovering patterns, spotting anomalies, testing hypothesis, checking assumption, and summarizing statistical and graphical representations. Okay, EDA starts by asking some basic questions, guys. Okay, so we can start EDA by asking some basic questions for data sets to make initial assessments. Okay, is there any existing unique record ID? It's going to check. So if I get a data, this EDA, so what are the things we can do? We should make a plan. Okay, so are fields populated with numbers, dates, or alphanumeric characters? What is the distribution of numeric values? How many value exists for categorical fields? How many fields have been left blank? How are multiple data sets related? Okay, these are the basic questions which you can expect as, which is the basic question which can arise by using this EDA. Is there any existing unique record, or this is the same record? Unique ID means is nothing but, guys, 1, 2, 3. This is unique, right? If I have 1, 1, 1, this is same thing. Unique ID record, it is there or not? And are fields populated with numbers? What is the distribution of numeric values? How many values exist for categorical fields? How many fields has been left blank? Null values, guys, nan and null, right? Nan and null. And how many multiple data are related? The data sets are related. So this data is related to something customer ID, and this data is related to customer name. Is this data sets are related by using some methods? Okay, these are the things we can do in EDA, guys. Okay, so moving on, we are going to go for the next thing. EDA, exploratory data analysis, consists of graphical and statistical. We have seen the slides, guys. This exploratory data analysis consists of graphical and statistical analysis. Okay, so what is this graphical analysis? So this graphical analysis is nothing but univariate analysis. See, univariate means one, guys. Okay, bivariate means two. The name itself indicates bivariate. I know you guys have been studied at the school times also, right? Bivariate means two, multivariate means multiple. The name itself indicates univariate, bivariate, and multivariate. Okay, Univariate analysis. It's analysis on one variable to summarize the variable. Example, bar plot, histogram, and box plot. Okay. This univariate is nothing but single analysis, which has single thing. This analysis on one variable to summarize the variable. Okay, which has only one variable, guys. An example for that is bar plot and histogram and box plot. So in the upcoming sessions, we are going to see how we are going to implement in the histogram, how we are going to implement in the box plots. So what are the plots we can get? What are the diagrams we can see? Okay. And the next thing we are going to see is bivariate analysis. So bivariate analysis is on two variables to determine relationship between them, which has two variables. Univariate means one variable. Bivariate means two variables. Okay, which has two variables, which can determine relationship between them. Example for that is scatter plot, guys. Okay, so bivariate means two. So basically, we are going to see what type of variate analysis we are going to need that. So how we are going to explain that. Okay, so multivariate means it's multiple, guys. Multivariate, the name itself indicates multivariate analysis. So multivariate analysis is nothing but just multiple. Okay, the analysis of multiple variables to determine interrelationship between them. So we are gonna see the interrelationship between them. Example them is pair plot and heat maps. Okay, pair plot and heat maps. Okay, so these are the difference between this univariate, bivariate, and multivariate, guys. We are going to see how we are going to implement in this in the upcoming session. So how we are going to use. So we need bivariate, or we need multivariate, or we need bivariate. So what are the charts we can see? Okay, so this is what all about this exploratory data analysis and the graphical analysis. Okay, this is all about graphical analysis, guys. Okay, I assure that it is clear. So moving on, we are going to see statistical analysis. This is very important, guys. 4 stages of business decision. Okay, it is called as 4 stages of business decision. 4 stages of what are the 4 stages of business decision? Someone is going to ask you. You should say we have 4 stages of decision. First is first moment business decision, and we have second moment business decision. We have third moment business decision. We have fourth moment business decision. Okay, we have 4 moment of business decision, guys. So what is first moment of business decision is called as? So first moment of business decision is called as measure of central tendency. Okay, measure of central tendency. Example is mean, median, and mode. We know where we are going to use mean, where we are going to use median, where we are going to use mode, right? So mean, median, the centroid values, remember, right? And mode and everything. So I'm going to explain you more deeply when you are going to go for the coding and theoretical part, guys. So it will be very easy for you to understand there. Okay. So for now, you have to understand what is meant by first moment business decision. So first moment business decision is also called as measure of central tendency, right? An example is mean, median, and mode. So as first moment of business decision is done, we're going to go for second moment business decision. So what is the second moment business decision is called as? Is called as measure of dispersion, guys. Okay, second moment business decision is called as measure of dispersion, variance, standard deviation, and range. And third moment business decision is called as measure of asymmetry. The skewness we are going to see when it is left skewness, what is it is called? When it is right skewness, what it is called? When it is how to get it is normal distributed. Okay, we are going to see that, and we are going to see what is meant by fourth moment business decision. It is called as measure of peakedness or tailness. Kurtosis, guys. Kurtosis, skewness. Okay, we're gonna see. So when skewness is normally distributed, whether it is 0 or when it is 3, or what is kurtosis when it is equal to 3 or when it is 4. So when it is decided, we are gonna see how we are gonna see the business decision. So there are 4 moments of business decision, guys. One we have is first moment, second moment business decision, third moment business decision, and fourth moment business decisions. Okay, these are the 4 stages of business decision, guys. 4 stages of decisions. Okay, be aware of that, guys. We have 4 stages of decisions. Okay, so moving on, let me explain about typecasting. So here we have pre-processing, guys. We have come to pre-processing. Pre-processing types. So we have typecasting, handling duplicates, outline analysis treatment, zero and non-zero variance, discretization, missing value, dummy variable, transformation, standardization, and string manipulation. Okay, so we have these many types of preprocessing, guys. So let me show you the another way where you can get the result very quickly. So I'm going to open the mind map from 360DigiTMG. So it will be very useful for you. Okay, so let me open that. So when we are going to data science mind map, here we can see different type of pre-processing, guys. So this is a mind map from 360DigiTMG, guys. It is very useful. It will be keeping on updated when there is new contents are added, new terminologies are added. Okay, so please do follow that. Please do follow YouTube also. So you'll get some ideas how to get to know about all the topics. You can attend the deployment part from Sharath sir and Barney sir. Okay, so moving on, guys. Typecasting. This is data pre-processing, guys. So let me write it down for you so I can remember that. This is pre-processing. Okay, pre-processing types. Okay, so typecasting. I said typecasting. Typecasting is nothing but converting one type to another data type. Okay, typecasting is nothing but converting one data type to another data type. Okay, converting float to integer. We can call it like that. Okay, what are the examples, sir? So if you're going to ask me the examples, you can see integer to float, right? Integer to float. So guys, this is pre-processing types. Okay, we have pre-processing types. In that we have typecasting. So one is typecasting. Typecasting is nothing but converting one data type to another data type. Means converting integer to float. Okay, this is all about typecasting, guys. So we are going to use this typecasting because we need to convert one data type to another data type. Okay, in our data. So what is handling duplicates? So here you can see getting single source of truth from various entries in one such examples. So let me say how to handle duplicates. Okay, so what is handling duplicates? So let me say there is a column. Okay, there is a column. Okay, and there is one more table. Okay, and we have the same number here. Okay, one. The column name is same, the table name is same. Okay, so do we need this? We have the same thing in table A also, and in table B also we have the same thing. Do we need that? Okay. So as we are saying about handling duplicates, guys. So what is this handling duplicates? So as I said, A and B are the same thing. One. So in column in table A and table B, we have the same thing. Guys. See, do we require this? No, right? So if the one column matches, that is enough, right? So like this, we are going to handle the duplicates, guys. So we are going to handle the duplicates, which we don't require. The column A and column B is the same. Why do we require two columns? It's going to store our data. There will be no loss of data, guys, because we have the same thing. Okay. So if you're going to go for some codes, you can see, you click on codes, double click on that. You're going to see how to drop that. Okay. If you want to see the data is duplicated, type data.duplicated. If you want to drop that, type data.drop duplicates. So this command is going to drop the duplicates whichever we have in our data set, guys. Okay. This is one important thing. So you can see follow the mind map of 360DigiTMG. We will be keep on updating what are the things you require to become a data science or data analyst or anything. Okay. So this is very good, guys. So focus on following the mind map every day. Okay. So handling duplicates is done. We are going to go for outlier analysis treatment. So what is this outlier analysis treatment? Okay. So I'll give a simple visual for you. Okay. So let me say there is some data sets, data points. Okay. If the data point slides here, okay, this is called as outlier analysis treatment, which is behind the range where it can be reached. Okay. See here, the data sets are here where it can be matched, but the data set is very far. Okay. This farness is called as outliers. Okay. Outlier analysis treatment. To how to solve this? So we have the data point here. How to solve this? Okay, how to solve that? We have some techniques, guys, which can be used to solve this outlier analysis treatment. So outlier analysis treatment is nothing but which the data point is far from there, okay, which has some high values, you can say, which has some extreme values. Okay. So to solve that, we have some techniques. It is called as 3R technique: rectify, retain, and remove. So we are going to use 3R technique, guys. We are going to rectify the data. We are going to see what are the possible ways we can do to rectify it. We are going to retain some data. Okay. Okay. Let's say this data is important for me. We are going to retain that. And after applying that, we are going to remove the data. So 3R technique is nothing but rectify, retain, and remove. So we are going to apply that. We are going to remove, which is not very required for us. We are going to retain. We are going to rectify. We are going to do these things using this outlier analysis treatment using 3R techniques. Okay. So 3R technique is done. So we are going to see what is meant by masking, guys. The next thing we are going to see is what is meant by masking. Okay. So what is masking, guys? So how it is used? So why do we need this masking? Here you can say outlier exists but fail to detect. Right? You're going to see outlier exists but fail to detect. You can see in the last session we have seen false negative, true positive, true positive, true negative, and everything, right? So in this, the same concept here you can see masking. Outlier exists but fail to detect. This masking is going to give us false negative, guys. There is an outlier here. You can see there is an outlier, but this outliers, it is this masking will not able to identify that. Okay, you can see masking outlier exists but fail to detect. Okay, this is called as false negative in purpose of masking. Okay, so this was all about masking, guys, and we're going to go for swamping. What is swamping? It's going to detect non-outliers as outliers. So you can see here, it's going to detect non-outliers as outliers. So masking, what it's going to do, it outlier exists, but this masking is not able to detect that. That is false negative. Negative, guys. Negative. The name itself says negative. This is a negative one thing, right? Outlier is there, but it's not able to detect means it is our negative thing. So it's false negative. Swamping, detecting non-outliers as outliers. Okay, it's going to say that is not an outlier, but swamping is going to detect that as outliers. Okay, so that is called as false positive. Okay, the main concept for this outlier analysis statement is, guys, Winsorization. Okay, the main thing is Winsorization. So what is this Winsorization? Where it is used? If anyone asks you what is the best method for this removing outlier analysis statement, you can say without any fear it is Winsorization. Okay, what is Winsorization? This technique modifies the sample distribution of random variables by removing outliers. Okay, if anyone asks you what is an outlier analysis treatment, can you give me any methods which they can solve it? You can go for Winsorization. This technique modifies the sample distribution of random variables by removing outliers. Okay, if you are confused with this terminology, you can see what is the example. 90% of Winsorization means all data below 5th percentile is set to 5th percentile, and all data above 95% is set to be 95th percentile. Means what are the 90% Winsorization is there? It's all data below 5th percentile is set to 5th percentile only, and above 95th percentile it is set to 90th percentile, guys. Okay, so Winsorization is nothing but a technique which modifies the sample distribution of random variables by removing outliers. Okay, so Winsorization is done. If you want to go for code, what is the code for Winsorization? Here you can see from feature engine. Okay, the from feature engine. This is the library, guys. Okay, feature engine. From feature engine dot outliers import Winzorizer. Okay, from this library we are going to say from feature engine dot outliers import as Winzorizer. Okay, from feature engine dot outliers import as Winzorizer. Okay, so this is all about Winsorization. And if you go for trimming, so trimming is different than Winsorization. See here when I type on that, you can see trimming is different than Winsorization. Guys, in Winsorization is gonna, here you can see the technique modifies the sample distribution. It's gonna modify the sample distribution of random variables by removing outliers. It's gonna remove the outliers. It's not just gonna cut the data. Okay, it's gonna remove the outliers where it is. But in this trimming, it's gonna trim down the data, means cut down the data. So what happens if you do trimming? There'll be a loss of information, right? There will be a loss of information. Okay. So in alpha, is said as 5%, then lower and upper 5% values are trimmed or removed. Here you can see what happens if we trim or remove. We are gonna lose the information. We are gonna get loss of information, guys. Okay. Trimming is different than Winsorization. As I said, we are using this Winsorization. Okay. We are using this Winsorization for modify sample distribution of random variables. So trimming, it's gonna remove the outliers. Okay, it's gonna remove the outliers. So we have seen what is meant by outlier analysis treatment and what are the techniques we can use it for, right? So moving on, we are gonna go for zero and non-zero variance. So usually we ignore the columns with the same entities throughout of majority the entries are same. So let me give an example. Here you can see all entries of column called country show the same name as USA. Zero and non-zero variance, guys. So zero and non-zero variance is nothing but we are going to use that. Okay, whenever we get the zero and non-zero variance, if the columns are same, let me if the columns say, you can see the example. If the column called country shows the same name as USA, right? If it is gonna give us the same name, so let me say there is one data set which has only the name USA. So we need that. We know there is only one name country called USA. We are not gonna get so many things, right? There are so many tables. Let's consider 5 tables. Okay, but the country name is all the same thing, the USA only. Are you gonna include all time the country name? No, right? There will be usage of large store of data. The country name is same. We know how to remove that country and we can just add it here. So the country will be the same. Or else if we do add everything, guys, it's going to take a large data. Okay, it's going to take some space where we can save some space, right? We need to save the space where the this trading and test can be easy, where we can get the codes to be done very easily. Okay, where we can run the program easily. Okay, so this was all about zero and non-zero variance. And if we go for missing values, so let me say missing values. Okay, so there is a table, and here it is V, I, J, and there is some column 10, 10, 20, and 0, 10, 0. So missing values. Here you can see there is a missing of value, nan or null. Okay, if there is missing of value, sometimes the data set may not type to occur, guys. Okay, it's not going to run. So we are going to use how to solve that. We are going to use imputation. Okay, we are going to use imputation. So what are the variants we have in imputation? So we use imputation to solve the missing values. Okay, variants missing completely at random. Okay, it's MCAR. It's a variance, guys. Missingness at random. Missingness not at random. So these are the variants. We're not going to concentrate too much on that. So if anyone asks what is missing values, there are some values which may be missed in data set. To solve that, we are going to use imputation where we can get some values. Okay, we can make the data set run. So what are techniques we have for these missing values? We have deletion methods, simple strategies. Okay, case-wise deletion or list-wise deletion or complete case analysis. And we have pair-wise deletion or available case analysis. So these are deletion methods. Okay, these are techniques of discretization, guys, means the imputation. Okay, techniques of imputation. Single imputation methods. We have mean imputation, median, mode, random imputation, hot deck, regression imputation, and KN imputation. So moving on further, we are going to see what about KN and KPs and all, guys. So model based, we have maximum likelihood, means multiple imputations. Okay, so these are what is meant by missing values and imputation. And if you go for discretization, guys, if we call discretization, converting continuous data to discrete data. So we always need continuous data when we're going to perform something, right? But here it's gonna convert continuous to discrete data, guys. And we have some technique in that. What is binding called? What is grouping called? If I click on binarization, you can see converting continuous data into 2 categories. So here discretization means converting continuous data to discrete data. You can see discretization means converting continuous data to discrete data. So binarization, what is binarization? Binarization is nothing but converting continuous data into two categories. Here, discrete data, binarization means it's going to convert continuous data, but it's going to convert into two categories, guys. Okay. So what is rounding? Rounding is nothing but, guys, that we can round it to the nearest value. Okay. So let me explain you that. So rounding to the nearest value, example 5.6 will become 6. So you know, if you go to any things, we are going to say if it is more than 5.6, it is nothing but 6, right? Or let me say if it is my percentage, if your percentage is 8.7 something CGPA, we're going to call it as 9. Okay, we are going to round off to the nearest values. Okay, so if let me say if it is some product is on 98 rupees, you're going to say it as 100 rupees, right? So the product was 100 rupees, something like that. Depends on like that, guys. We are going to round off to the nearest value where we have. If it is 5.5, 5.4, we are going to round it off to the 5. It is more than 5.6, we are going to round off it to 6. Okay. So this is what is meant by this, guys, rounding off method. If it is less than 5.5, we are going to call it as 5. If it is more than 5.6, we are going to call it as 6. Okay. That is done of rounding. Next, we are going to see is binning. So what is this binning? So we have two types of binning, guys. Something but discretization of grouping. You can see we have two names for that. So converting continuous to discrete data is called as discretization. Okay. Binning, we have fixed with binning and adaptive binning. So these are the two methods, guys. Okay. In binning. So discretization is done. We are going to go for dummy variable creation. So why do we need this dummy variable creation? So dummy variable creation is, there are so many types, guys. Okay, we're gonna see it in the practical part. Okay, so I'm gonna explain you its similarity. We have one-hot encoding, label encoding, dummy coding scheme, effort coding, and we have bin counting scheme, and we have feature hashing scheme. So effect coding scheme, dummy coding scheme, these all schemes. We are not going to see that much, guys. But one-hot encoding and label encoding, it's gonna see our projects. Okay. So what is this one-hot encoding? Let me explain. Which has 1 and 0s, guys. Okay. True or false. You can call it true or false. Okay. 1s and 0s. PD.getDummy is df.drop first is equal to true. If my first column is true, give it as true, or else give it as false. From sklearn.preprocessing, import one-hot encoder. So how to import this one-hot encoder? What is the library we need? We need from sklearn.preprocessing, import one-hot encoder. Okay, from sklearn library, we are gonna import this preprocessing one-hot encoder. Okay, I assume that is clear. So I'm gonna go for label encoding. So what is this label encoding? Label encoding is nothing but in practical we can see that. Okay, so this label encoding from sklearn.preprocessing, import label encoder. So how to import label encoder? From sklearn.preprocessing, import label encoder. So we are going to use library of sklearn.preprocessing. Okay. So that is all about dummy variables creation, guys. We are going to go for transformation. So we're going to transform the data. Okay, where we need to transform the data. Then doing it, we can we are going to transform the data. Check for normal distribution, log, square root, reciprocal. So these are type of transformation we can use, guys. Okay. And moving on, we have standardization, normalization. So why do we need this standardization or normalization? To make data scale free and unitless. The main thing, guys, why do we need this standardization and normalization? We need this standardization or normalization. It will make the data scale free and unitless. Okay, to make the scaleless and unitless, you can see standardized scaling. Okay, x mean dot we have standard deviation. Okay, mean is 0 and standard deviation is 1. Minimum max scaling, range method, right? And we have robust scaling. Okay, so these are types we have in standardization, guys. And if you're going to go for string manipulation, we have so many things in string manipulation, guys. Tokenization, converting sentences to words. Okay, NLP, guys. NLP. So let me write it down properly for you. Converting sentences to words. Okay, NLP, natural language processing. Okay, is nothing but natural language processing. Natural language processing. Okay. What is in that? We have gonna see tokenization. What is tokenization? Converting sentences to words. Okay. So just know a brief about that. So you're gonna see in theoretical morely. Stemming and lemmatization. So what is meant by stemming and lemmatization? Stemming, guys, it's gonna reduce the infected words to their base forms. So what is that infected words? I'm gonna show you an example. Okay, stemming means it's gonna reduce the infected word to their base forms. Like we have study, and we have history, and we have story. So it's gonna reduce to its base form. It's not gonna give the complete, which is the correct value. It's gonna go into with their base form. It's gonna give history. It's gonna give like this. Okay, where it's gonna reduce the infected word, but it's gonna take it to its base form. So, but lemmatization. So I know you'll be getting an idea what is meant by this lemmatization after saying stemming. It's gonna reduce the infected words to correct form, the dictionary form. You can call it as dictionary form. Okay. If you have same example, history, and story, right? If we have this, it's gonna give us the complete name, which is from dictionary form. It's gonna reduce the infected words to their perfect form, the dictionary form. Okay. So I assume that is clear what is meant by that. Stop word removal. So what is meant by the stop word removal? We are gonna remove the word ing in the stop word removal. Okay. So if I has stemming, it's gonna remove the ing. Okay, it's gonna remove ing. So this is called a stop word removal. And remaining all we will be seeing, so it will be very easy to understand when we go on to the moving steps. Okay, document similarity, topic models, and word embeddings. Okay, this was all about pre-processing, guys. Okay, so we have seen what are the different type of pre-processing and all. So we have seen the moment decision, right? 4 stages of business decision. So first moment of business decision, we have measure of central tendency, mean, median, and mode. It's also called as average. It gets influenced by outliers. If you click on median, you can see middlemost value set. I said median. The name itself indicates median, and doesn't get influenced by outliers. This mode, it's nothing but a maximum times, right? It's a single mode. You can see the what are types of mode we have. Okay, this is measure of central tendency. So what is this second moment based decision? We have there is a measure of dispersion. We have variance. Disadvantage is that of this variance is it's the units get squared in the test. And in standard deviation, square root of variance. Advantage is that we get back our original input from squared units. Okay, range. Range is nothing but maximum and minimum, guys. Okay. So third moment business decision. We have skewness. As I said, what type of skewness we are going to see, right? If the skewness is negative, if it is on left skew, right? The skewness is left like this, it is called as negative skewness. If it is right, of course, it is called as positive skewness. Okay. So when we get it is normally distributed, sir. So it is normally distributed. Skewness is equal to 0, then it is normally distributed, guys. Okay, skewness is equal to 0, then it is normally distributed. Okay, that is third moment business decision. And fourth moment business decision, the kurtosis, right? So we have different types, guys. Here you can see the skewness is 0, then it is normally distributed. But if kurtosis is equal to 3, then here it is normally distributed. In skewness, if skewness is equal to 0, then it is normally distributed. But in kurtosis, if it is 3, then it is normally distributed. Okay. So here in the In skewness, we saw if it is negative skewness, it is on left side. But here we have particular name, guys. Okay, if it is left side, it is called as platycitric. Okay, if it right side, it is called as leptokurtic. Okay, so this is what is meant by kurtosis, guys. So leptokurtic is nothing but positive, and platycitric is nothing but negative. Okay, so these are what type of business decision we have seen. So moving back to the slide, guys, we are gonna go for what all the things we have to see, right? So pre-processing is done. So as we know, pre-processing is done. So let us move on, guys. So what is this pre-processing as various steps? So what are the various steps of this pre-processing? So we're going to remove HTML tags. We are going to remove extra white spaces. We are going to convert accidental characters to ASI characteristics. We are going to expand contractions. We are going to remove special characters. What is meant by the special characters is nothing but, guys, so this type of is called as special characters. We are going to lower all texts, means we're going to lower, because why we need to lower all case, right? So let me say there is one data set which has more than 50,000 data set. Okay, so here there is a, if 50,000 data set, let me say it's 30,000 something. Are you going to search the data every time? No, right? It may be like this, and it's going to throw you error, guys. Okay, so that is the reason we're going to make all the lowercase. Wherever the data set we have, we're going to make it to the lowercase. So there will be no problem, right? If all data set is smaller case. Okay, we're going to lower all the texts. That is meant by that. Convert numbers to words to numeric form. So we are going to convert number words to numeric form, guys. We're going to convert it. Okay. So moving on, we're going to remove the number which is not required to us. We are going to remove the stop words. We have seen, right, what is meant by stop words. And lemmatization also we have seen, where it's going to convert to its, yes, it's going to convert to the word to the dictionary form. Okay, so moving on, we are going to see what is meant by data mining. Okay, so data mining, guys, and this genomics and proteomics. Okay, data mining, it is a search for hidden trends within large sets of data. Okay, data mining, basically we are going to use it to search hidden trends with large set of data. Okay, this data mining, guys, it is very important. Okay, this data mining is basically, it is a process of sorting through large data sets, guys. Okay, it is very important in sorting through large data sets. It's going to identify the patterns and relationship that can help to solve business problems through data analysis. Okay, so this data mining is a process of sorting through large data sets. It's identify the patterns, relationships that can help to solve business problems through data analysis. Okay, these data mining techniques and tools enable enterprises to predict future trends and make more informed business decisions. Okay, so it is nothing but the process of sorting through large data set to identify patterns and relationships that can help to solve business problem through data analysis. Okay, so moving on, we have seen what is meant by data mining, and we're going to see the approaches are needed. At what levels, what approaches are needed? We need genomics and proteomic analysis. These studies can provide a wealth of information, guys. So data mining approaches are needed to different levels. These provide wealth of information rapidly, generate large quantities of data from analysis of biological specimens from healthy and diseased tissues. Okay, these genomics and proteomics, it's going to give us the information which is very wealthy for us. Analysis of biological specimens from healthy and diseased tissues. The high dimensionality of data generated from these studies will require development of improved bioinformatics and computational biology tools, where we can get the accurate data of analysis. Okay, so data mining, here you can see data mining, genomics and proteomics, right? So these are things we have, this genomics and this thing, proteomics. We have computational biology and bioinformatics. Okay, the science and biology, guys. In general, see, you can see The computer science and biology in general are central to the future of biological research. Okay, this data mining. Okay, this data mining in genomics and proteomics. It is the future of biological research, guys. Okay, the discipline span process that begins with data collection, analysis, classification, integration, and ends with interpretation, modeling, visualization, and prediction. So these are the things. It's going to process begin with data collection. It's going to go with analysis, classification, integration. It's going to end with interpretation. We are going to do modeling, visualization, and we're going to do prediction also, guys. Okay. So data mining plays a role in the middle of this process. So this data mining is very important, guys. It's may plays a crucial role in the all this process. Okay. Overall, the focus is on identifying opportunities and developing computational solution. So overall, this focus is into identifying opportunities and developing computational solutions. Okay, that can be used for experimental design, data analysis, and interpretation and hypothesis generation. Okay, it is very important, guys. This data mining is very important. Identifying the opportunities, developing computational solutions. Okay, and that can be used for experimental design, data analysis, interpretation, and hypothesis generation. Okay. So this how it is very important, guys. Okay. So let's move on. So let's move on, guys. So moving on, we are going to see feature selection and genomic and proteomic data mining. Okay. We are going to see this feature selection. Okay. So feature selection, we are going to see ensemble feature selection in medical data sets. We are going to combining filter, wrapper, and embedded selections. Okay. So combination of this thing will. So the combination. So we are going to see the combination of feature selection. So what are the algorithms offer the best performance? So different type of medical data. We're going to see experimental results. We are going to show what are the combination of filter and wrapper. We are going to see which is the better choice using this ensemble feature selection. Okay. So we are going to move on with the next session of day 4, guys. So we are going to see, so today's session we have been completed with EDA and pre-processing, right? So tomorrow session we are going to see what are the practical things we can implement. So please be available to the next session so we can apply what are the things we need. Okay. So thank you for attending the session.